Okay, so we got a problem that basically tells you a graph f of x and use that graph to solve an equation, right? Okay, so here's f of x, here's your equation. Well, let's graph it. There's the graph. Everybody knows how to do that, or really I hope they can. Okay? And then we want to solve the equation two to the x equals 2 minus c over 10. Now c is the number of letters in your last name, may be modified a little. In my case, it's modified a little, it's 6. Okay, well what's 2 minus 6 over 10? I chose 10 for the denominator so you don't have to do a lot of tough arithmetic, right? Or at least, no, you don't have to approximate anything. 6 over 10 is 0.6. And 2 minus 0.6 is 1.4, right? Now, I assume you can do that arithmetic, because if you can't, you're probably not able to do the rest of it anyway, so you need to bone it up. Okay? But there it is, right? Everybody okay with that? Pretty straightforward. You just plug in whatever C is for your name and divide it by 10, you get a decimal, subtract it from 2, you get this. And you don't have to do fractions because the decimals are easy, and you are going to want the decimals anyhow so you can locate these things on the graph. So, you know, here's your y, now and here's your x. Okay, so let's see, y here is 1, here it's 2, then you're going to have 3 here, and then you're going to have 4 up here. Well, where's 1.4? 2 to the x has to equal 1.4, right? Well, this is your 2 to the x. Y equals 2 to the x. So your y value is 1.4. Here's 1.4. Project down, that looks like about x equals 0.7. So estimated solution, x equals 0.7. I don't care if you put the 0 point there, but if you're in the habit, that's fine. Okay? As long as you have a 0.7 there. Yeah, everybody follow what I just did? It's something we've been doing for years. Well, weeks, months. Okay? But one reason you picked this problem is you might not have known how to read it. That's why I want to address these things, okay? So that makes sense? You kind of do that with every problem. Now, it also tells you to solve the thing, I think. Solve the thing and see how close you were, right? Okay, so now we got to do, okay, now 2 to the x equals 1.4. So x equals log base 2 of 1.4. Right? And log base 2 of 1.4 is the log of 1.4 divided by the log of 2. And you do a calculator, right? And you find that my estimate wasn't very good at all because it's really pretty close to 1/2. My estimate wasn't great. We're in the right ballpark, but I kind of missed. Of course, I just slopped down the graph. I wasn't careful with my scale or anything. But I'm surprised I missed by that much. I didn't think it was that bad a graph. I was kind of proud of it. But now I'm just horribly disappointed in it, but I've got to leave it up there. You know, so posterity can see that I made a bad graph or something. Did I do anything? You see anything else I did? Is 1.4 about right? If this is 1 and this is 2, I think that's not bad. And yeah, the more I look at it, the more horribly I'm disappointed. And it's a fault of the graph, it's not my fault. Okay. Well, okay, I'll take responsibility. That's what you do with the rest of these, right? 2 of them are logarithmic, 2 of them are exponential. If you know how to change logarithmic to exponential or vice versa, and almost everybody that's handed these in has done it just real well on problems that are much harder than this one. This one just turn it around using the rule and evaluate it. Now, if you were doing this and you got to this point and didn't know how to use your calculator, you wouldn't be able to make the comparison, so I'd have to take off a point or two. Because I want you to make the comparison. So you really need to know how to do that, okay? If you just get to here without writing this, well, you're supposed to know this. That's how you evaluate it. There's another point off. But if you got to here and this right, you'd at least get 7 points out of 10, which isn't too bad, okay? So just to give you an idea how I look at these and how I grade them. Now, if you solve the equation correctly and don't know how to do the graph, well, I'll give you half credit, but that's being generous. I don't mind being generous. Okay? Because you can solve the equation, that's worth something. Okay? But I want to see both, and I want to see the comparison. Make sense? Fair enough? Yeah, you can say no. Doesn't matter. That's what it's going to be. I hate to disagree. Okay. So I don't think that one is particularly difficult. I don't think 9 is particularly difficult at the beginning. By the time you get to the end, you've got to use several things. If you do it one step at a time, I think most of you would be able to muddle your way to a half-decent score. And many of you would be able to solve the whole thing, right? So if you're muddling, keep muddling until it starts taking too long to muddle, and then go on to another problem and come back when you got time. Okay? So this says, graph the polynomial P of X, and you got to know the order of operations. You got to be able to write things right, which is challenging to me, I guess. Okay? And these are all multiplications, and they don't really all look like it, but now they are. Okay? Now everybody understands that that's the first thing. It's 1 divided by this quantity, which you write like this. It's going to be a simple fraction. And then you multiply that. Even though the parentheses isn't here, it doesn't hurt to put it there to remind yourself. First thing you do is the division. 1 divided by that quantity, right? And then you're multiplying that by everything else. So the next thing is a multiplication, and it's just x plus a times x minus b times x squared plus c. Now we plug the numbers in. For me, this is 1 over 4 times 5 times 6 times x plus 4. Actually, it's x plus 5. Okay, that should be 5, and that should be 4. And x minus 4, and x squared plus 6, which is 1 over, that's 24 to 144, times x plus 5, times x minus 4, times x squared plus 6. So that's just a matter of, again, writing the thing down, using the order of operations. Turns out on this one, if you mess up the order of operations, you can still answer a lot of questions. Like if you put this whole thing in the denominator, it's still going to have zeros. You know, a lot of what you would do with a polynomial would still work. You'd get the right signs and all that. So, and it's a harder problem, so if you happen to get it right, I'd probably just complain, but I wouldn't penalize you, okay? I think you're much more likely to get it right if you read it correctly, though. Okay, so what's the average rate of change with respect to x on an interval of length 2 centered at x equals a? Now I'm going to assume we know that in my case a is 5 and you know what it is in yours, so I'm just going to write that down, okay? What do I mean by an interval of length 2 centered at x equals 5? Well, if you've sketched a reasonable graph, at least you'll know that the zeros are at -5 and 4. And x squared plus 6 can't be 0, because x squared is never negative, and anything that's not negative added to 6 is going to give you a positive number, right? So in this case, this thing's never 0. Now in the case you get, you might not have a square there, okay? You might have something else, okay? But in this case, those are the zeros, and between -5 and 4, yeah, you have positive, negative, positive, which gives you a negative. It's below the axis. To the right here, positive, positive, positive makes it positive. To the left here, you have negative, negative, positive, which makes it positive. And you know that the number is going to get really big as you go off to the right, so it's going to do this. It's going to get really big if you go off to the left, as we discussed last time. Now, if you don't get the end behavior right, as long as you give it a try, I probably won't penalize you much, okay, if at all, because we haven't discussed that as thoroughly as I'd like. And we'll come back to it when we come back from break. But this means that your graph basically looks like this. It's not exactly a parabola, but it looks a whole lot like one. It's a little lopsided. The vertex isn't right in the middle. And that's because you got to multiply it by this, and this keeps changing as you go from here to here. So you might not, you don't need to understand that right now, although eventually it'd be great if you do. Okay? So now I've got an approximate graph. Now I want an interval of length 2 centered at x equals 5. Where is that? What's the first thing you want to try to get if you're going to get that interval? Better know where x equals 5 is, right? Well, you'll nail that one. I'm confident in all of you. Okay? If there's 4 and there's -5, then 5 is about here. And I don't care if it's totally accurate, as long as it's reasonable. Even if it's unreasonable, if you get the right answer at the end and you just screw up your scale or something like that, depending on what I'm asking you to do, I might not even penalize it. Okay? Now, you want an interval of length 2 centered at 5, right? So where does that interval start and where does it end?
4 and 6.
Okay, it's got a length of 2. So here's now an interval of length 2. Its center is 5, right? So how far does it go to the right of the center if its length is 2? Well, the middle is in the middle, so it's as far from the right as the left, so it's half the length, right? And half the length is 1. So it should be clear that an interval of length 2 centered at 5 is the interval from from 4 to 6. And could you find the slope on the interval from -4 to 6? Yeah, you just sketch the fundamental triangle. Here's your fundamental triangle. It actually starts at 0, which is easy and nice, and ends here. So it depends on how fast this thing goes up, but that probably puts you to a point up here. So you draw your fundamental triangle. Its run is what? 2. Okay? I remember you've had problems for weeks where I ask you to find the average slope or construct the fundamental triangle for a given interval, right? That's all it means. Okay, you can sketch it, you can reason it out. Your run is 2. Your rise, you're going to have to evaluate this function. Well, I'm not going to go through that. You've got the function, right? Oh, what the heck, I'll evaluate it. Okay, you're going to get 7. Wait, we're at 6. That's 11 times 2, which is 22, times 42. 22 times 42 is 840, and 84 is 924, if I'm right. Unlikely, but it could be. 924 divided by 144 is a little over 5, 6, sorry. Okay? So I'm going to say this point is maybe 6.3. Now, just dumb luck if the 0.3 is right. It could be. Okay? But, as I say, it'd just be dumb luck. Actually, it's a little more than that. Probably close to 6.5. Anyhow, this point is 0.4. So your rise is 6.3. That's a slope. Now, if I ask you for the rate of change, average rate of change on that interval, average rate of change is the slope of the fundamental triangle on that interval, right? Okay? We defined that by mid-January. Okay? So you might have to review a little bit. So I asked for the average rate of change, which is why I drew the triangle, right? So it says average rate of change is the slope of the fundamental triangle. Okay, so this problem asks you in sequence to do a number of things that if you've done everything, you know how to do. And if you haven't done everything, I just told you how to do that one. It's going to be on here. Okay, these problems are going to be pretty predictable. Okay? But they're asking you to do some fairly sophisticated stuff and hopefully put it together. Okay? So even though you know what's coming, it's still very good if you can do it at this point. Okay? I'll also mention, I regard this as a fairly hard test, so the grading scale will be reasonably lenient. Except for the A's, you got to be good. Okay? It gets more lenient as we go down. Because, like transfer institutions get more lenient as we go down in the general rigor of the institution, and there's a lot of difference between institutions. Okay? And that's why my grading scale is kind of a rubber band scale. It stretches as we get down to the lower grades. It only stretches so far, and you should know that. Okay. And I tell you there, you fine to use your calculator to calculate that average rate of change. Okay? Because you're not going to calculate that 6.3 or whatever it is in your head. If you do calculate it in your head and give me a good approximation, I probably won't know the difference because I won't look that closely. I assume you can punch your calculator. Now, if you get a ridiculous number here, I'll notice it. If it looks about right, I'll probably accept it, but still be careful because you never know. Sometimes it's really important. On this one, I'm just looking, do you know the method? You get a reasonable evaluation of the number. Now, ask you the same thing centered at A. Cut. I had an editing error there. I just asked you the same thing that I asked before, but I think on the test, I'll double check it, that's a different letter. Okay? So that would be an interval of length 0.2 centered at like B. Okay? And I might not use B, but anyhow, you can do it. Whatever that number is, you do the same thing I did here on that interval. Now, one of the intents is that one of those intervals would be where the thing goes through one of the zeros. Okay? So I might ask you for the average rate of change on this interval. Okay, so that would be the interval -6, -4, so you'd have to use this point and this point. So you would have this triangle. The run is still 2. To get the rise, you just plug -6 in here, and you plug -4 in here to get the y coordinates, to get the rise. I think I said, I don't know what I said. Okay? And then I said sketch a line segment through the point A0 having this slope. Something I should add here. When you sketch your graph, and I should add that, I'm going to add that to the statement of the problem. And I just made myself a note to actually do that, and then I tried to put the chalk onto the end of the Sharpie, holding the cap to the Sharpie in my mouth, knowing darn well I was not holding the chalk in my mouth. You can figure that out. Okay, just pointing that out. So what I'm adding to this is I want you to label the Y-intercept. Okay?
Yeah. And the field is closer too.
Okay.
I think
Well, that means you go over here to the y-axis and you draw yourself a y-axis, and then you figure out what the y-intercept is. Well, the y-intercept occurs when x equals 0, right? And if x equals 0, you get 5 here, -4 here, and 6 here, right? It looks like that's -144. Actually, it's not, because I can't multiply. This isn't 144, it's 120.
Have a wonderful spring break, Sarah.
I multiplied 6 by 4 by 6. 6 times 24. So let's just pretend I hadn't done that. So now this is 120. And this is now 120 into 924, was it? Okay. 120 goes into 968 times. That's going to be like, not 6.3, that's going to be like 7.6 or 7.7. Okay. Okay, well anyhow, we label the y-intercept. And we get 120 here, but it's negative, right? And we do this. So I'm just going to say P of 20 equals negative, P of 0 equals -1. Meaning that the y-intercept here is at the point 0, -1. Now you can do that for any function. Of course, you have to know that the y-intercept occurs when x equals 0, just like you need to know that x-intercepts occur when y equals 0. Okay? And I think people know that. I mean, people didn't seem to have any problem with that when we did it, but I want to remind you because it could get away from you. Yeah?
This is a little bit off topic from like the question, but I think 120 goes into 900 7.5 times.
120? Okay, but it goes into 944, 7.7
I
times.
didn't have that last part.
Huh?
I didn't have that last part.
Do what?
The 44.
Well, I don't have 144 anymore.
Well, I mean, that last part I didn't. The 900. Never mind.
The 144 I got was at x equals 0. The 924, whatever it was at x equals 6. And I divided it by 144 because I made a bonehead error here. So I just corrected it. This is really 120. That really comes out, I think, pretty close to 7.7. Okay? If I remember that it was 924, and I don't want to, it's 840 and 84, yeah. But actually, yeah, that's 924. Okay. Now, the key thing we're trying to do here, though, is this thing where I say draw a line through this point, having the slope that you get at this point, right? Okay, well, I don't want to do this. You would think, well, the line would be about parallel to this one. But now we have a scale. We have a scale where this is 1 on the y, and you can scale this is about 1 on the x, right? So when you calculate that slope and honestly draw a line with that actual slope, it's probably not going to match the slope of your original graph, which means you'd have to modify your original graph. Okay? Now, if you calculate that slope and don't know what to do to graph it, I'm not going to regard that as a major error at this point. Okay? But there's a point to it, so you want to try to do exactly what it says. And don't assume that you drew the graph right. You could easily draw the graph too steep or too shallow, right? In which case the slope here won't match the scale. Okay? And that's an important point that I think some of you will get, and if you don't, as long as you do the calculations right, I'm not going to get terribly penalty-minded on it. So the rest of these questions are more subtle questions, okay? If you do everything up to calculating the slope and locating this point, getting these rates of change, I can guarantee you at least 9 points and probably 10, okay? And if you get the harder questions, I might even give you a couple extra points. So it's worth trying. Okay, well, moving along here with the hardest problems, but let's, number 11 also don't understand transformations and can't get it by reviewing or think you'd get it another way, email me for a access code. Okay? I finally got one email. I'll tell you what section. It's done nice and systematically with good videos. Okay? And of course you can Google it. There's lots and lots, millions of videos on it. It's extraordinarily important for understanding functions. In fact, I have a meeting right after this, and I'm tasked with basically coming up with a very important test that's given to everybody to assess whether we're doing general education right. My part is the math part, as you might expect. You might prefer I had the English part because I come up with something really stupid and easy. But, you know, I'm dumb that way. Actually, I talk pretty good, don't I? My grammar done be good.
I get you. I can have some articles too.
Yeah, thank you. Okay, so anyhow, but I researched it finally, kind of at the last minute, because I got a meeting in 23 minutes. Well, gotta present something. And one of the big problems I had in developing, or deciding what to do is, are we doing one test that covers people that take pre-calculus and also people in technical curricula and also people in like liberal arts related curricula? Because that gets really weird. But anyhow, I found some really good information on pre-calculus based mathematical literacy as opposed to statistics based mathematical literacy as opposed to logic based literacy, which is actually mathematical.
Strange question for you.
Transformations are a big deal. That's all I'm saying.
Strange question for you, kind of pertaining to that. Well, if you were to come up with basically a standardized test for all of them, couldn't you take the average answers for each set of people and
Yeah, you can do that, but it's a waste of time for people who are not ever going to take pre-calculus to have to look at pre-calculus problems.
What I mean is, like, you could turn it into a function and that would give a standardized grading scale for people with different.
Yeah, you can do all kinds of things with the mathematics of those results, and that's one of them. And we could easily do it, but we don't want to waste people's time with tests that aren't relevant to them. Anyhow, so all number 11 is do transformations. So the way it's stated might give you a heart attack, but that's the way things are supposed to be. No. The way it's stated is you do a f of x, which is just what? Vertically stretch the graph of f of x, right? By factor a. Okay, every point moves a times as far from the x-axis. If a is negative, it moves on the other side. If a is smaller than 1, it moves closer, right? We've talked a lot about that. Then a f of x minus h. What's that? Well, after you vertically stretch it, you shift it h units in the horizontal direction. That's the rule. Hopefully you understand the reason for the rule, but that's the rule. And you remember the rule better if you understand why. Okay? And then we got a f of x minus h, so that's k. So after you shifted h units, you're going to vertically shift it k.